Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the area for trapezium practice questions. If you need any extra help on finding the area for trapezium, if you go to corbettmaths.com/contents and scroll down to video number 48, there's a video tutorial there on how to find the area of a trapezium. Alternatively, you can scan this QR code. But in this video, we're going to go through the video solutions to the practice questions, so let's get started. So question number one. Now, just before we do question number one, I'm just going to recap what the area for trapezium is. So here's a trapezium. We've got the two parallel sides. Let's call the top A and the bottom B. And the distance between them is the perpendicular height of the trapezium. So the formula to find the area for trapezium is given by area equals a half, and then in brackets A plus B, and then times the height h. So to find the area for trapezium, we use this formula, a half, brackets A plus B times h. In other words, if we've got our trapezium, we add together the lengths of the two parallel sides, A and B. We then half that, and then times by the height, h. So that's it. So let's use this formula to answer our questions. So let's start off with question number one. So question number one says, below is a trapezium ABCD. So ABCD, it's a trapezium. And we've been asked to work out the area of the trapezium. So we need to work out the area of this trapezium. So the area of a trapezium is given by the formula, half, brackets, A plus B times the height h. So that's how we find the area for trapezium. We add together the lengths of the two parallel sides, we half it, and then times by the height. And if we have a look at our trapezium, the two parallel sides will be the top and the bottom. They are the two parallel sides, the top and the bottom. So I've labelled those A and B. Now h is the distance between them. So if we look at the distance between those two parallel lengths, those two parallel sides, that will be 3 centimetres. So the height of our trapezium is 3 centimetres. And this diagonal, the length of it isn't needed to work out the area of the trapezium, so we don't actually need this 5 centimetres to work out the area of this trapezium. So now let's work out the area of the trapezium. So it's a half, and then in brackets A plus B. So A, the length of one parallel side, is 6 centimetres, and B is 10 centimetres, so that's going to be 6 plus 10. And then times by the height is 3 centimetres, so times by 3. Now we need to add together our 6 and 10 first of all. What's inside our brackets? Think of your order of operations, your brackets, your orders or indices, divisions or multiplications, additions and subtractions. So we need to do the brackets first of all. So 6 plus 10 is 16. So that's going to be a half of 16 times 3. A half of 16 is 8, so we've now got 8 times 3, and 8 times 3 is equal to 24. So the area of this trapezium is 24 centimetres squared. And that's it. So to find the area of this trapezium, we've added together the lengths of the two parallel sides, so 6 plus 10. We've halved that to get 8, and then we've times by the height, which is 3, and 8 times 3 is 24. So the area of this trapezium is 24 centimetres squared. Okay, question number 2. Okay, let's have a look at question number 2. So question number 2, we've got our trapezium, and it's a non-calculator question, and we've been asked to work out the area of the trapezium. So the area of our trapezium is given by the formula, area equals a half, and then in brackets, A plus B, times the height h. So let's substitute in our values. So we've got a half, and then in brackets we've got A plus B. So that's 9 plus 15, the two parallel sides, 9 and 15, so 9 plus 15. And then times by the height of the trapezium, which is 4 centimetres, so times by 4. So now let's work out what's inside the brackets. So 9 plus 15, 9 plus 15 is 24, so half of 24 times 4, the height. A half of 24 is 12, so we've got 12 times 4. And finally, 12 times 4 is equal to 48. So that means the area of this trapezium would be 48 centimetres squared. And that's it. So just to recap, we've added together the lengths of the two parallel sides. 9 plus 15 is 24. Half that to get 12. And then 12 times 4 is equal to 48. And that's it. So question number 3. Question number 3 says, shown below is a trapezium. So we've got this trapezium, and we've been asked to calculate the area of the trapezium. So the area of a trapezium, area is equal to half, brackets, A plus B, times the height h. So we're going to add together the lengths of the two parallel sides, half it, and times by the height. So let's find out what our A, our B, and our h are in our diagram. So if we have a look at our trapezium, the two parallel sides at the top and the bottom here, so that's going to be our A and our B. And h is the distance between them, the perpendicular height, so that's going to be 4.5 centimetres, so that is our height. The 6 centimetres, that length of that diagonal, we're not going to need that to find the area of the trapezium. So let's substitute those values into our formula. So the area is equal to a half, and then in brackets A plus B, so it's going to be 5.2 plus 10.8, and then we're going to times by the height, which is 4.5, so times by 4.5. Now we need to work this out, so we're going to do our brackets first of all, so 5.2 plus 10.8. Now it is a calculator question, and if you do 5.2 plus 10.8, we're going to get 16. So we've got a half of 16 times by the height, which is 4.5. A half of 16 is 8, so we've now got 8 times 4.5. And then if we do 8 times 4.5, that would be our area. So 8 times 4.5 is equal to 36. So the area of this trapezium is 36 centimeters squared. And just to recap, we added together the lengths of the two parallel sides, the 5.2 and the 10.8, to get 16. We half that to get 8, and then we times by the perpendicular height. 8 times 4.5 would be 36. So the area of this trapezium is 36 centimeters squared. Okay, question number 4. So question number 4 says the diagram below shows a shed wall. So here we've got a shed wall. The height of the left-hand side is 2 meters, the height of the right-hand side is 3 meters, and the width of the wall is 7 meters. And we've been asked to work out the area of the wall. Now this trapezium is a little bit different than the ones we've looked at so far, because so far the parallel lines have been the top and the bottom. Now if you turn your head sideways, you can look at it the same way, so that the 3 would be on the base, the 2 would be the top of the trapezium, and the 7 meters would be the height of the trapezium. So you can do that if you want to. Alternatively, we could just use our formula, area equals a half brackets a plus b times the height h. A and B are the two parallel sides. So if we have a look at our diagram, we've got these little arrows, and they're telling us that this side is parallel to this side. So our A would be 2 and our B would be 3 meters. And our h, the distance between the two parallel sides, would be 7 meters. And then we can just substitute those into our formula. So we've got a half brackets A plus B, so it's going to be 2 plus 3, times the height, which is 7. So we're going to do a half of 2 plus 3, so 2 plus 3 is 5, so that's going to be 5 times 7. And a half of 5 would be 2.5, so 2.5 times 7. Now this is a calculator question, so we can just do 2.5 times 7, and that's equal to 17.5. So the area of this wall is 17.5 meters squared, or 17.5 square meters. And just to recap, we added together the lengths of our two parallel sides, so 2 plus 3 is 5. We halved it to get 2.5, and then we just multiply by 7, the distance between them, and that gives us 17.5 square meters, or meters squared. Okay, our next question. So question number 5. Question number 5 says, shown below is a trapezium. So we've got this trapezium, and we've been asked to work out the area of the trapezium. So the area of the trapezium, area is equal to half brackets a plus b times the height h. So if we have a look at our trapezium, we've got our two parallel sides, our 11 centimeters and our 18 centimeters, and we can see they're parallel from these arrows. So that's going to be our A and that's going to be our B. The height is the distance between them, so it's the perpendicular height, so it's the distance straight between them. So it's going to be 9 centimeters. The distance between them is 9 centimeters. That is our height. And the length of this diagonal, we don't actually need this to work out the area of this trapezium. So we're not going to use that 13 centimeters. So let's substitute those values into our formula. So we've got a half and then a bracket, A plus B. So that's the lengths of our two parallel sides. That's 11 plus 18. So 11 plus 18. Multiplied by the distance between them, the perpendicular height, which is 9 centimeters, so multiplied by 9. So we're going to add together what's in our brackets first of all. 11 plus 18 is 29, so we've got a half of 29 multiplied by 9. A half of 29, well, that's going to be equal to 14.5, so a half of 29 is 14.5 multiplied by 9. And then it's a calculator question, so we can do 14.5 multiplied by 9 on our calculator and see what we get. 14.5 multiplied by 9 is equal to 130.5 centimeters squared. So that's our area, 130.5 centimeters squared. Okay, let's have a look at question number 6. So in question number 6, we've been given a trapezium with some measurements. We've got this length is 6 centimeters, this length is 12 centimeters. There are our parallel sides, our A and our B. And we've got the height of the trapezium, which is x. And we don't know x yet, but we're probably going to have to work it out. And we're told the area of the trapezium is 63 centimeters squared, and we've been asked to work out the value of x. So we need to find the height of the trapezium. So we know the area of the trapezium is 63 centimeters squared. So that means that if we use the formula area equals a half brackets A plus B times the height, we would get 63 centimeters squared if we know the values of A, B and H. But we don't. But we do know that the answer is equal to 63. So let's write that down. 63 is equal to a half. And then in brackets, we know our A and our B. Our A is 6 and our B is 12. So let's write 6 plus 12. And then that's multiplied by the height. Now we don't know the height, but we've been told it's equal to x, so let's write down multiplied by x. Now we would normally work out our bracket, so we would do 6 plus 12, so that would be 63 is equal to a half of, now 6 plus 12 is equal to 18, so a half of 18 multiplied by x. We would now half this, half of 18 is equal to 9, so we get 63 is equal to 9 times x. Well, 63 is in the 9 times tables. 9 times 7 is equal to 63. So you might be able to work out at this point that this would have to be 7. Alternatively, we could solve this like an equation. We've got 63 is equal to 9x. We don't want this multiplied by 9, so we're going to divide both sides of the equation by 9. So divide by 9 and divide by 9, and we get that 7 is equal to x. So x is equal to 7 centimeters, and that's it. And we can check our answer because we can add together our 6 plus 12. 6 plus 12 is 18. Half that, that's equal to 9, and then multiply by 7 is equal to 63. So our height must be 7 centimeters. Our value for x must be 7 centimeters. Okay, let's have a look at our next question, question number 7. So question number 7, we've been given a trapezium, and we've been given one parallel side is 6 centimeters. The height of the trapezium is 4 centimeters, and the other parallel side is x. And we've been given the area of the trapezium is 34 centimeters squared, and we've been asked to work out the value for x. So let's again use our formula. Area is equal to a half, and then in brackets, a plus b times the height. So the area is equal to half a plus b times the height. The area is equal to 34. And that's equal to half of, and then in brackets, a plus b. So our two parallel sides would be the top and the bottom. So that means that a would be equal to 6, and our b would be equal to x. And then that's multiplied by the height of the trapezium, which is 4 centimeters. 4. So we want to find out what x is, and we can work backwards here, because to find the area of the trapezium, which is 34 centimeters squared, we would add together the lengths of the two parallel sides, half it, and then times by 4. So let's divide by 4. So 34 divided by 4, and it's a calculator question, is 8.5. So that's 8.5. And that's what this would be equal to. This part would be equal to 8.5. Because whenever we add the two sides together, the two parallel sides together, and half it, that must be 8.5. So then whenever we multiply by 4, we get 34. So that would be a half of 6 plus x. So we've added together the length of the two parallel sides and halved it to be equal to 8.5. So if we do the opposite, so double our 8.5, that's equal to 17. So that would tell us what the two parallel sides added together is equal to. So 6 plus x is equal to 17. And well, 6 plus 11 is equal to 17, so x would have to be equal to 11, and that's it. So the value for x here would be 11 centimeters. So in this question was a little bit different. We were given the area, and we were asked to find the length of one of the parallel sides. So we worked backwards. We took our area, we divided it by the height to give us 8.5. We doubled it to get what the two parallel sides added together would be, which was 17, and then we took away 6 to leave us with 11, and that's it. Okay, let's have a look at our next question, question number 8. So question number 8 said, a club logo is made from a square, so here's our square, and a trapezium here. And we've been asked to calculate the area of the logo. So let's find the area of the square first of all, and then find the area of the trapezium, and then add them together, and that'll be the area of the logo. So let's start off with the square, so square. So the area of the square is equal to the length times the width. The length would be 4 centimeters, the width would be 4 centimeters. 4 times 4 is equal to 16 centimeters squared. So the area of the square is 16 centimeters squared. Now we want to find the area of the trapezium. Now if we have a look, the square and the trapezium are joined together. So as you can see here, this length is the same as this length. So that means that this length is equal to 4 centimeters. So we've got our trapezium, we've got our two parallel sides, the 4 and the 8, and we've got the height, the distance between them. So for our trapezium, the area is equal to a half, brackets, a plus b, times the height, h. So a half, and we've got our a is equal to 4, and our b is equal to 8, and our height of our trapezium would be equal to 2 centimeters. So that'd be a half, and then in brackets, a plus b would be 4 plus 8, and then times by the height, the distance between them, which is 2. So let's work this out. So let's add our two parallel sides together. 4 plus 8 is equal to 12. So we've got a half of 12 multiplied by 2. A half of 12 is 6, and then we're going to multiply by 2. And 6 times 2 is equal to 12 centimeters squared. Let's just check it. To get the area of this trapezium, we've done 4 plus 8 is equal to 12. Half that is equal to 6, and then 6 times 2 is equal to 12 centimeters squared. So the area of this region, this trapezium, is 12 centimeters squared. And then to get the area of the logo, we're going to add together the two areas, the area of the square, which is 16, and the area of the trapezium, which is 12, and 16 plus 12 is equal to 28. So the area of the logo is 28 centimeters squared. Okay, let's have a look at our next question. Question number 9. So question number 9, we've been given a triangle and a trapezium, and we're told that the area of the trapezium is 4 times the area of the triangle. Find x. So this time we've been given the triangle and the trapezium. We can work out the area of the triangle to begin with because we know the base of the triangle. We know the height of the triangle, so we can do half the base times the height to get the area of the triangle. And then we can use that information to then find the area of the trapezium, and then we can find x. So let's start off with our triangle. So our triangle, the area of the triangle is equal to half the base times the height. So a half of the base, well, half of 20 would be 10. So a half of the base, 20, multiplied by the height, which is 21. So the height is the distance straight up to the top. The 29 is the diagonal, so we don't actually need to use that. So we're going to do half of 20, which is 10, times by the height, which is 21, which is equal to 210 centimeters squared. So the area of this triangle, using half the base times the height, is 210 centimeters squared. 210 centimeters squared. Now the trapezium. With this trapezium, we've got the two parallel sides, A and B, and we've got the height, which is 24 centimeters, and the area of the trapezium is 4 times the area of the triangle. So 210 multiplied by 4 is equal to 840 centimeters squared. So the area of that trapezium is 840 centimeters squared. So let's write down the formula. So the area of the trapezium is equal to half, and then in brackets A plus B times the height, H. So the area is 840 is equal to a half, and then in brackets A plus B, so it's going to be X plus 48, so X plus 48 times by the height of the trapezium, which is equal to 24, so times by 24. So we've got the area, 840, is equal to half of the sum of the two parallel sides, X plus 48, times by the height, 24. Now at this point, we could work backwards. We could divide by 24, we could then double it, and then we could take away 48, and that would tell us the length of this side. Or another approach we could use is, if we look at this formula, half of A plus B times H, we don't have to half the A plus B. We could half the height instead, and then times by A plus B. As long as you're halving at some point, you're finding the area of the trapezium. So rather than halving our X plus 48, I'm going to half 24, because multiplying by 24 and then dividing by 2 is the same as timesing by 12 anyway. So we just half of 24. So whenever we do that, we get 840 equals, and then we're halving 24, so that's going to be 12, and we're timesing it by this bracket. So I'm just going to put the 12 in front of the bracket, so 12 X plus 48. So just half the 24. So we've now got 840 is equal to 12 times X plus 48. So 12 times something is equal to 840. So if we divide 840 by 12, or both sides of this equation by 12, we'll find out what this is. So dividing by 12 and dividing by 12, well, divide by 12 and divide by 12. 840 divided by 12 is 70. And we're dividing by 12 to get rid of the 12, so we're just left with X plus 48. And we don't need to write that in brackets, we just write X plus 48. So we've got the 70 is equal to X plus 48. So with the number we're trying to find, plus 48 is equal to 70. So if we do 70, take away 48, that's equal to 22. So that means that the length of the top of our trapezium, this distance, the length of this parallel side, A, is equal to 22 centimeters. And we can check our answer. We could use the formula, A plus B, so 22 plus 48, and just doing this on the calculator, is equal to 70. Half that is equal to 35. And times by 24 is equal to 840 centimeters squared. And that's 4 times the area of the triangle, so we know we're right. So that means that the length of X is equal to 22. So 22. Okay, let's have a look at our next question. So question number 10. Question number 10 says, shown below is a rectangular garden. So we've got this rectangular garden, which has got a length of 20 meters and a width of 16 meters. And there's a flower bed in the shape of a trapezium. So we've got this trapezium flower bed in the middle. And we're to work out what percentage of the garden that the flower bed covers. So we want to find what percentage of this whole garden does this flower bed cover. So let's find out the area of the whole garden, and let's find out the area of the flower bed, and then we can work out the percentage. So let's start off with the whole garden. So the whole garden. So it's a rectangle, so we're going to use the length times the width, so we're going to do 20 multiplied by 16 is equal to 320 meters squared. So that's the area of the whole garden. Now the area of the trapezium, so the area of the trapezium area is equal to a half, and then in brackets A plus B times the height. So if we look at our trapezium, our A and our B, our two parallel sides would be 6 and 13, so that's the A and the B, and the height is equal to 5 meters, the distance between them, 5 meters. This 9 is the length of a diagonal, and we don't need it. So to find the area of this trapezium, we're going to do is equal to a half of A plus B, so it's going to be 6 plus 13, times by the height, 5. So that would be 6 plus 13 is equal to 19, so that's going to be half of 19 times 5. Half of 19 is 9.5 times 5, and 9.5 times 5 is equal to 47.5 meters squared. So we've got the area of the whole garden, and we've got the area of the flower bed. Now what we can do is write that as a fraction. So the fraction of the garden that the flower bed covers is 47.5 out of the 320 metres. So that's the fraction of the whole garden that the flower bed covers. Now if we divide, because remember the change of fraction to a decimal, we can divide. So dividing that would give 47.5 divided by 320 is equal to 0.148437.5. And then to change that to a percentage, we can just times by 100, so that would be 14.84375%. So that is the percentage of the whole garden that the flower bed covers. And that's it. So we just wrote that as a fraction. So we wrote the area of the flower bed out of the area of the whole garden. So that is a fraction. We converted that to a decimal by dividing and then just changed that to a percentage. And let's just round our answer to 2 decimal places. So that would be 14.84% to 2 decimal places to 2 decimal places. Okay, let's have a look at our next question. Okay, let's have a look at question number 11. So question number 11 says, Walter would like to plant a crop in the field below. So we've got this field below, and we're told that each 8 kilogram bag of seed costs £56. And 1 kilogram of seed covers an area of 50 square meters. And Walter has £380 to spend on seed for the crop. Does Walter have enough money to cover the entire field? So let's start off by finding the area of the field. Now this field, we could split this into a rectangle and a triangle. So you could split down here vertically, and you could find the area of this rectangle, so 45 times 55. You could then get the area of the triangle and then add them together. So that's one possible way to do it without using the trapezium. But I'm actually just going to show you that you could use the area of the trapezium to do it also. So we could split it into a trapezium and a rectangle. So let's find the area of the rectangle to begin with. So the area of this rectangle would be 25 multiplied by 45, the length times the width, and that would be equal to 1,125 meters squared. So that's the area of the rectangle. Now this trapezium. So this trapezium, we've got one parallel side is 60 meters. The other parallel side is 45 meters. So we've got our A and our B. So A is equal to 45 and B is equal to 60. And then the height of the trapezium. Well, we've got this distance is 25 meters and this whole length is 55 meters. So if we wanted to find the height, the distance between them, this length here, we would do 55, take away 25, and that's equal to 30 meters. So we've got this trapezium where we know that A, RB, and RH, and we can find its area. So for the trapezium, we would do area equals a half, and then in brackets, A plus B, so it's going to be 45 plus 60, so 45 plus 60, and then we're going to times that by the height, which is times by 30. So when we work that out, 45 plus 60 is equal to 105, and half that is equal to 52.5 multiplied by 30, and 52.5 times by 30 is equal to 1,575 meters squared. So the area of this region, the trapezium at the bottom, would be 1,575 meters squared. So to get the area of the whole field, we're going to do 1,125 plus 1,575, and that would be equal to 2,700 meters squared, or square meters. So that's the area of the whole field. And then we're told each 8 kilogram bag of seed costs £56, and 1 kilogram of seed covers an area of 50 meters squared, or 50 square meters. So if we were to divide this field into 50 square meters, each one of those 50 square meters would need a kilogram. So if we divide 2,700 by 50, that would tell us how many 50 square meters there would be, and if each one of those needs 1 kilogram, that would tell us how many kilograms of seed we'll need. So 2,700 divided by 50 is equal to 54. So that means we're going to need 54 kilograms of seed. So Walter's going to need 54 kilograms of seed. Now each 8 kilogram bag costs £56, so let's see how many bags he needs. So let's divide his 54 kilograms he needs by the 8 kilograms, how much he gets in each bag, to see how many bags he needs to bag. So 54 divided by 8 is equal to 6.75, so 6.75. Now, unfortunately, Walter's not going to be able to go into the shop and say, can I have 6.75 bags? So he's going to have to buy 7 bags. So he needs 7 bags of seed and 7 bags, and each bag costs £56. So we're going to do 7 times 56 and see what we get. So 7 times 56, the cost of each bag would be equal to 7 times 56 is equal to £392. So to buy the 7 bags of seed, which would be enough seed to cover the whole field with a little bit extra, it would cost Walter £392. Now unfortunately there's no smaller bags or anything like that we've been told about in the question, so it's going to cost him £392 to cover the whole field. He's only got £380, so does he have enough to cover the entire field? The answer is going to be no. He's going to be a little bit short. He could buy perhaps 6 bags and then leave a little bit of field not covered in seed or something like that. Okay, so let's have a look at our next question. Okay, question number 12. So question number 12 says, shown as a cardboard box that is a prism. So we've got this cardboard box that is a prism. So it's got a trapezium as the cross section and it's a prism. So it's a trapezoid prism. And we've been asked to calculate the surface area of the box. So this box, this prism has got 6 faces. It's got the face on this side, the right hand side, the left hand side, the front, the back, the top and the bottom. Okay, so we need to get the area of those 6 faces. So we need to get the top, the bottom, the left, the right, the front, and the back. Okay, and we need to get those 6 areas and then add them up to get the total surface area of the box. So let's start with the top. So the top of this prism, if we have a look, it's a rectangle. It's got a length of 10 centimeters. So this length is 10 centimeters. So from here to here is 10 centimeters. That's 10 centimeters. It's got a width of 5 centimeters. So it's going to be 5 times 10, and 5 times 10 is equal to 50 centimeters squared. So the top has got an area of 50 centimeters squared. 5 times 10 is equal to 50 centimeters squared. Okay, we've now got the bottom. Well, if we have a look at the bottom, it's going to be a rectangle as well. It's got a length of 10 centimeters and a width of 3 centimeters. So if we do 3 times 10, that'll be the area of the rectangle on the base of the prism. So 3 times 10 is equal to 30 centimeters squared. So the area of the base is 30 centimeters squared. So we've got the area of 2 faces. Now we've got the left and the right. So let's look at the left hand side, so this side here. It's a rectangle as well. The height of the rectangle will be 12 centimeters, and the width of the rectangle will be how wide it is, how long the prism is, which is 10 centimeters. And if we do 12 times 10, that would be the area of this left-hand face, which would be equal to 120 centimeters squared. So that's 120 centimeters squared. So we've done 3 of the faces. We've done the top as a rectangle, so we've done 10 times 5 is 50. We've done the base, which was a rectangle as well, so we've done 10 times 3, which is 30. And we've done the left-hand face of this trapezium, and it was 12 high, 10 wide. 12 times 10 is 120 centimeters squared. Now let's do the right-hand face. So if we have a look at it again, that is a rectangle. So it's a rectangle there. The length of the rectangle is 10 centimeters. The height of the rectangle is 8 centimeters. 8 times 10 is equal to 80 centimeters squared. So the area of the right-hand face is 80 centimeters squared. So we've done 4 of the faces. Now we need to do the front and the back. Now the good thing is, with this being a prism, they're the same, because with a prism it's got that constant cross section. So whenever we find the area of the front, that's going to be the same as the area of the back. So let's look at this area of the front. So let's look at this shape. This shape is a trapezium. If we actually rub out some of our lines here, it'll help us. So let's rub out these red lines. So we've got this trapezium, and this trapezium has got 2 parallel sides. So the 2 parallel sides would be our 12 centimeters, our A, and this parallel side here, it's got a height of 8 centimeters. So as you can see, it's 8, so that's 8, so that's 8, so that's going to be our B. 8 centimeters is our B. So we've got our 2 parallel sides, 12 and 8. And then the distance between them, if we turn our head sidewards, the distance between them is 3 centimeters. That is the distance between them, 3 centimeters. So that is our H. So we can then work out the area of this trapezium. So the area, let's write the front, would be a half. Area is equal to half, brackets A plus B, times the height H. So it's going to be a half, and then A plus B, so it's going to be 12 plus 8, so 12 plus 8, times by the height, which is the distance between them, which is 3, so times by 3. So working out our brackets, 12 plus 8 is equal to 20, so half of 20, multiplied by 3. A half of 20 is 10, so 10 times 3, and 10 times 3 is equal to 30. So the area of this trapezium is 30 centimeters squared. So the area of the front is 30 centimeters squared. Now the back of the prism has the same shape, that same trapezium as the front, so that means the area of the back would be 30 centimeters squared also. So if we add together 50, 30, 120, 80, 30 and 30, that would give us the surface area of this box. So let's do that. And that's equal to 340 centimeters squared. So the surface area of this prism is 340 centimeters squared. So that means the surface area of the box is 340 centimeters squared. Okay, let's have a look at our next question. Question number 13. Okay, let's have a look at question number 13. So question number 13 says, a design is made using a semicircle and a trapezium. So we've got this semicircle and we've got this trapezium, and we need to find the area of the design. So let's find the area of the semicircle to begin with, and then find the area of the trapezium. So let's deal with the semicircle to begin with. Now if we look at a semicircle is half of a full circle. So if we pretend this is a full circle, so we pretend that is a full circle there, and if we find the area of the full circle, we can then half it to find the area of the semicircle. So we want to find the area of this circle. So we're going to use the formula pi r squared. So the radius of the circle, we've got the diameter of the circle is 20 centimeters. That means that the radius of the circle is 10 centimeters. So if we do pi times 10 squared, that will give us the area of the whole circle, and then we can just half it. So pi times 10 squared, so that's going to be pi times 10 squared. That's a calculator question. So pi times 10 squared is equal to 100 pi, or 314.1592654 and so on centimeters squared. So that's the area of the whole circle, but we want just the area of the semicircle, so we're going to half that. So we're going to do 314.159 and so on divided by 2. So I've left that answer on my calculator display, and then I'm just going to press divide by 2 equals, and that is equal to 157.0796327 centimeters squared. So that is the area of the semicircle. Now we need to find the area of the trapezium, and then we can add them together. So let's consider now the area of the trapezium. So I'm just going to rub out those little dashes for our imaginary full circle. So we then have our shape 2, which is our trapezium, so shape number 2, and the area of the trapezium is given by the formula half brackets a plus b times the height. So that's the area of a trapezium. Let's label our A, B and H. So our A and B are our parallel sides. So A is going to be 20 and B is going to be 12. They're our parallel sides, and our height is going to be 10. That's the distance between them. So our area is equal to half A plus B, so it's going to be 20 plus 12 times by the distance between them, which is times by 10. So let's work that out. 20 plus 12 is equal to 32, so half of 32 times by 10. A half of 32 is 16 times by 10, and 16 times 10 is 160 centimeters squared. So we've got the area of the semicircle, 157 point blah 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 blah. We've got our area of our trapezium, which is 160, and if we add them together, that will give us the area of the design. So 160 plus 157.0796 and so on. So I've already got this on my calculator display. I've left it there. So plus 160 is equal to 317.0796 and so on. And I'm going to round this to one decimal place. That would be 317.1 centimeters squared. And that's it. So 317.1. Okay, let's have a look at question number 14. So question number 14 says a garden ACDF is a trapezium. So we've got this trapezium, and we're told the garden is divided into two sections: a patio, ABEF, so this section is a patio, and the lawn, BCDE, so that's a lawn. So we've got the garden, and it's been divided into two sections, the patio and the lawn. And now the question says, given the area of the patio to the area of the lawn, the ratio is 4 to 5, find the length of BC. So what we need to do is we need to find this length. That's what the question is asking us to work out, the length from B to C. That's what this question wants us to find out. But we're told that the ratio of the area of the patio to the area of the lawn is 4 to 5. So if we can work out the area of the patio, which we can then find the area of the lawn, and then if we know the area of the lawn, we can then find the length of BC. So let's start off by finding the area of the patio. So let's start off with the patio. So the patio. So if we have a look, the patio is a trapezium. We've got the two parallel sides, so we've got our A and our B, so 20 and 47 are the two parallel sides, and the height, the distance between them, is 32. So if we use that, we can find the area of the patio. So the area is equal to a half, and then in brackets, 20 plus 47 times by the height, the distance between them, which is 32. And whenever we work that out, we get 20 plus 47 is equal to 67, and half of that, so half of 67 is equal to, and when we multiply 33.5 by 32, we get that's equal to 1072 meters squared. So the area of the patio is 1072 meters squared. So that's the area of the section. So we found the area of the patio, which is 1072 square meters. So we now need to find the area of the lawn. But we're given the ratio, and we're told that for every 4 square meters of patio, there's 5 square meters of lawn. So if we divide the 1072 by the patio number in the ratio, the 4, and then times by 5, that would tell us the area of the lawn. So if we do 1072 divided by 4, that tells us how much is in one part, which is equal to 268. And then if we take our 268 and multiply that by 5, that would tell us the area of the lawn. So times by 5 is equal to 1,340 square meters. So the area of the lawn is 1,340 square meters. So what we've done is we took the area of the patio, we divided it by 4, and then we times it by 5 to find the area of the lawn. So in this question, we've been asked to find the length of BC. Let's call that y. Okay, so we want to find this length. And we know the area of the trapezium. We know the length of one of the parallel sides. So let's call that A. Let's call y B. They're the two parallel sides. And we know the height of the trapezium. The distance between the two parallel sides is equal to 32 meters. So that means that we can use that information to find out the length of y, that length of BC. So for the lawn, we know that the area is equal to half of A plus B times h. We know the area is equal to 1,340, and that's equal to half of, and then in brackets, A plus B, so it's going to be 10 plus y, so 10 plus y. And then we're timesing that by the height, the distance between them, which is times by 32. Now if we work out a half of 32, that's 16, so we get 1,340 is equal to 16 times 10 plus y, close brackets. Now we can expand our brackets here, so we get 1,340 is equal to 160 plus 16y, multiply both of these by 16, 16 times 10 is 160, and 16 times y is 16y. Now we would just want to solve this equation, so we want to get the y on its own. So let's get rid of the 160 by taking away 160 from both sides of our equation. So 1,340 take away 160 is equal to 1,180. That's equal to, now on the right hand side of the equation, we took away the 160 to get rid of the 160, so we're just left with 16y. And then if we just divide both sides of the equation by 16, we'll find y. So divide by 16 and divide by 16. So 1,180 divided by 16 is equal to 73.75, and that's equal to y. So if we go back up to our question, we know that's equal to 73.75 meters. And the question says find the length of BC, that is 73.75. 73.75, and that's it. So question number 15. So question number 15 says a trapezium is drawn below, and we've got a parallel side of 20 centimeters, another parallel side of 36 centimeters, and we've got our two diagonals which both have the same length. So one's got 17 centimeters and the other one is 17 centimeters. So that means that this is going to have a line of symmetry, this trapezium, okay, symmetrical, because both sides have got the same length. So that means that the 20 centimeters is in the middle of the 36 centimeters, so that these are the same length. And we've been asked in part A to work out, or to use Pythagoras' theorem to show that the height of this trapezium is 15 centimeters. So we want to use Pythagoras' theorem, so we want to look at this right angle triangle, so this right angle triangle here. We know that the diagonal, the longer side, the hypotenuse, is equal to 17 centimeters. Now we want to find the height of it, so we really need to find this distance here. Now as this trapezium has got a line of symmetry, this distance would be the same as this distance here. This distance is the same as this distance. So if we take 20 away from 36, so if we do 36 take away 20, that's equal to 16. So that means that this length plus this length is equal to 16 centimeters. But if we half it and do 16 divided by 2, that's equal to 8 centimeters. So that means that the distance from here to here is equal to 8 centimeters, and likewise that distance is equal to 8 centimeters. So that's great, because now we've got a right angle triangle, we've got the longest side of the triangle, the shortest side of the triangle, and we want to find one of the missing sides. So Pythagoras' theorem is a squared plus b squared equals c squared. So let's label our side. So a is the smallest, so that's going to be 8. B is going to be the next smallest, so one of the other shorter sides, b. And it doesn't actually matter if you label those the other way around, so b and a, but I tend to go for a and b. If I can put them in order, I try to, so a and b. And then our longest side is going to be our hypotenuse, which is c. So let's substitute our values into Pythagoras' theorem and work it out. So a squared is going to be 8 squared. Instead of a squared, it's 8 squared. Plus, instead of b squared, it's h squared. So h squared is equal to, and instead of c squared, it's going to be 17 squared. So now let's work out what our 8 squared and our 17 squared are. So 8 squared is 64 plus h squared is equal to, and 17 squared is 17 times 17, which is equal to 289. So we want to find out what h is. So we want to get rid of our squared and we want to get rid of our 64 to leave us just with h. So let's get rid of our 64 to begin with. So it says take away 64 and take away 64. So our left hand side of our equation, so we took away 64 to get rid of the 64, so we're just left with h squared. And our right hand side of our equation, we've got 289 minus 64 is equal to 225. So we've now got the h squared equals 225. Now we don't want the squared there, so we're going to do the inverse of squaring, which is square root to both sides. So the square root of h squared would be h, and the square root of 225 would be square root of 225 is equal to 15. So that means that h is equal to 15. So that's it. So the question asks us to show that h, the height of the trapezium, was 15, and we've done it. So the height here is 15 centimeters. Okay, part B. Part B says to find the area of the trapezium. So the area of the trapezium is given by half a plus b times the height h. So if we go back up, Our A and our B are two parallel sides, so let's label them again. So our A and our B of our trapezium are two parallel sides, so A and B, and the height of the trapezium is the height of it, which is 15. So A is equal to 20, B is equal to 36, and the H is equal to 15. So we've got equals a half of, instead of A, 20, instead of B, 36, and instead of H, that was times 15. And let's work that out. So 20 plus 36 is 56, so that's going to be half of 56 times 15. A half of 56 is 28 times 15, and 28 times 15 is equal to 420. So the area of this trapezium is 420 centimeters squared, so 420. Okay, let's have a look at question number 16. Now, to do question number 16, you're going to need to know Pythagoras' theorem. So if you don't know Pythagoras' theorem, go and watch that video on Corbettmaths now, or ask your teacher if they'll teach it. So here's a trapezium, and it's A, B, C, D is the trapezium, and we've been asked to find the area of the trapezium. So to find the area of the trapezium, we would do the two parallel sides added together, half it, and then times by the height of the trapezium. But in this question, we don't have the height of the trapezium, so we need to find it. So we're going to use Pythagoras' theorem to help us here because we have the length of this diagonal. So if we have a look here, we have got a triangle. If we come down here, that is a right angle triangle here. So this is our right angle triangle. We've got the length of the longest side, the side opposite the right angle. So that's our hypotenuse. And we want to find the height of it. We want to find this distance here. So let's find this length here. So if we have a look, the whole width of the trapezium from D to C is 8.7 centimeters. And this is a straight line, and the length here is equal to 3.6. So if we do 8.7 take away 3.6, we can find out the length of this extra part. So if we do 8.7 take away 3.6, that gives us 8.7 take away 3.6 is equal to 5.1, so 5.1. So that means the length from here to here is 5.1, and you can check that. 5.1 plus 3.6 is equal to 8.7, so that's right. So we now know this length is equal to 5.1. We know this diagonal is equal to 8.5 centimeters, and we want to find this h, this height of the trapezium. So let's call this length h. So let's write down Pythagoras' theorem. A squared plus b squared equals c squared. So A and B are the two shorter sides, and C is the longest side of the right angle triangle, the hypotenuse. So as you can see, this is going to be our C, it's the longest side, and A and B are the two shorter sides, so I'm going to call this A and this side B. So this is one of the shorter sides, and this is the other shorter side. And I've called it A and B because I think 5.1 could be the shorter side, and that B is slightly bigger, but it doesn't actually matter which way around you label them. You could call this B and this A, as long as this 8.5 is C. So let's substitute those into Pythagoras' theorem. So A squared is 5.1 squared, so 5.1 squared plus, and instead of b squared, that's going to be h squared is equal to c squared, which is definitely 8.5 squared. Now let's use our calculator. 5.1 squared is equal to 26.01 plus, and then we've still got h squared is equal to, and 8.5 squared is equal to 72.25. So we've got 26.01 plus h squared is equal to 72.25. So we want to find out what h is. So we want to get rid of this 26.01 and we want to get rid of this squared. So let's take away 26.01 from both sides. So take away 26.01 from both sides leaves us with, on the left hand side, h squared. And on the right hand side, 72.25 take away 26.01 leaves us with 46.24. So we now know what h squared is. Now we don't want h squared, we want to find out what h is, so we want to get rid of the squared. So we're going to do the inverse, which is square root both sides. So we're going to do h is equal to the square root of 46.24. And if we press the square root on our calculator and then answer, we get that's equal to 6.8. So that means that h is equal to 6.8 centimeters. So that means the height of this trapezium is 6.8 centimeters. So we've been asked to work out the area of the trapezium, and the area of the trapezium is a half bracket a plus b times h. So let's label our a, b, and our h. So a and b are the two parallel sides, and h is the height, the distance between them. So one parallel side of our trapezium is 3.6. The other one is 8.7, so that's going to be our b. And the height, the distance between them is, so 6.8 centimeters. This distance is the height. So let's substitute those into our formula. So we've got a half, and then in brackets, a plus b, so that's 3.6 plus 8.7 times the height, which is equal to 6.8. And when we put that into our calculator and work it out, we get 3.6 plus 8.7 is equal to 12.3, and divided by 2 is equal to 6.15, and then multiplied by 6.8. And when we work that out, we get that's equal to 41.82 centimeters squared. So that is the area for our trapezium. And that's it. So these have been the video solutions to the area for trapezium practice questions on Corporate Maths. I really hope you found this video useful. If you need any extra help on finding the area for trapezium, if you go to corbettmaths.com/contents and scroll down to video 48, there's a video tutorial there. Alternatively, you could scan this QR code. But anyway, I really hope you found this video useful. If you have found it useful, please like it, please subscribe to the YouTube channel, and thanks so much. Cheers, bye.